Alright, good day student. Today we'll be treating inverse of a function. Inverse of a function. This is supposed to be a lesson on 5.6. So inverse of a function. And under inverse of a function, we have other sections we are to be treated. The first is explore inverses of a function. The second is find and verify inverses of nonlinear function. Find and verify inverses of nonlinear inverses of what? Nonlinear function. So the third is solve real life problems using inverse function. Solve real life problems using inverse functions. So these are three sections we are going to treat in inverse of a function. So let's proceed, having known the three areas we are to be concentrated in inverse function. So let's go for the first one. So explore inverses of a function, and say exploring inverses of a function. So whatever way we are to explore, that is to know more of inverse of a function, of different function. Functions that undo each other are called inverse function. Functions that undo, cancel out. Undo means to cancel out each other, are called inverse function. So this is the first things you have to know. With the equation of the form, let's go into what we have today. With the equation of the form, y equals to f of x. With the equation of the form y equals to f of x, we can solve for x, which is the input from f of x, the output. Equation of the form y equals to f of x. This equation can enable us to solve for x. Solve for the value of x. The value of x, that is the input. The value of x, that is the input from the given function, the given function f of x, that is the output. So this equation will enable us to solve the value of x, which is the input, from the given function f of x, which is the output. And because we are still on the inverse function, so let's see how we can use this given equation to solve for x, and then we now proceed to know more of inverse of a function. So if you are told to solve y equals to f of x for x, then find, this is then find the input when the output is 2. then find the input, that is x, when the output is what? 2. Find the input when the output is 2. Already know what the input is, that is x. You have to find s. When the output, you know what is output? Output is equals to f of x. That is when the output is 2. So solve f of s for x, then find the input when the output is 2. You are given the first question, f of x is equals to s minus 2. So you are told when the output f of x is equals to what? 2. So the first thing we usually do in this case, since we already stated that y, equation of the form, is equals to f of x. So this is the equation we stated. Find the value of x when the output is equals to 2. In this case, the first thing is to set f of x, that make s f of x equals to y. Make f of x equals to y, then we have y equals to s minus 2. Is it not? If we set f of s equals to y, we have that y is equals to s minus 2. In this case, add 2 to each side. We are trying to make s the subject. If we add 2 to each side, we have y plus 2 is equals to x minus 2 plus 2. So that 2 can cancel out to give us x. This gives us s equals to y plus 2. So we have already then what the question is, solve y equals to f of s for x, then find the input. So this is the first thing you are asked to do for x, that is to make s the subject. So once you have done that, the second is to find the input when the output is what? Find the input when the output is 2. So the second question, already we got that s is equals to y plus 2, and the output is 2. So you are told to find the input when the output is 2. This will give us s equals to 2 plus 2, that gives us 4. So we are learning few things we have to know before we can define inverse function clearly. We are trying to tell you that the input you is equal, you put, and we give an output. So if we know the output, we can solve for the input. If you know the input, we can solve for the output. So the input by the equation, we can do that by using this equation. So the input is 4 when the output is what? Is 2. So the input is what? 4 when the output is what? 2. So let's do one more example, then we now go to real inverse, the definition of real inverse or inverse of a function. So the second question, we are solving for x. Find the input when the output is 3. In this case, we have 3. For our second question, have f of x equals to s minus 2 raised to power 2 minus 7. You were asked to find the input x when the output is 3. If we refer to this question, we always use it to simplify it. So we can say set f of x equals to y. We have been solving many equations involving f of x equals to maybe s plus 2. So we are solving it. This is the output of f of x. So but we really need to find the input. So for that reason, we assign another function y, which depends on f of x. So by solving for y and then making s the subject of the formula, we can now find the input. So set f of x equals to y. We now have y equals to x minus 2 all raised to power 2 minus 7. So how do we make s the subject? Add 7 to both sides. Add 7 to each side of what? Each side of the equation. If you add 7 to each side of the equation, you have y plus 7 is equals to y minus 2 raised to power 2. If you add it here, 7 plus 7 will give us 0. So it will be clear to have this. I hope you are following. So the next is to do what? To find the square root of each side. Square root of each side. Find the square root of what? Each side. So because this is 2, finding the square root, we have plus or minus. Remember when we treated radical and rational function, the square root of using square root method. So we have plus or minus. Each of these will satisfy the value of y. So we have y plus 7 raised to power half. This will give us s minus 2. So having done that, add 2 to each side. Add 2 to each side. So adding 2 to each side, we have what? Because of minus, if add 2 to each side, we have 2 plus or minus the square root of y plus 7. That will give us x. So whichever way you write it, it is the same. So this is the what we are required to solve for y. The next is to evaluate to do what? Find the input when the output is 3. So you can bring this value here. Already you have find the s is equals to plus or minus the square, whichever way addition is closed, y plus 7 plus 2. So bring it up so we can clear the board and solve for other values. So let's clean here. So from here we have gotten the value of x. The next is to find the input when the output is 3. Find x when f of x is equals to what? 3. F of x, which is equals to y. So in this case, we have x equals to plus or minus the square root of 3 plus 7 plus 2. So this gives us plus or minus the square root of 10 plus 2. Is there any mistake somewhere? Do we make mistake? What is our original value? So find, sorry, this is minus, sorry. Then find the input when the output is minus 3. So put minus here. Find the input when the output is minus 3. All you need to do is to minus 3 plus 7 will give us 4. So x is equals to plus or minus the square root of 4 is 2 plus what, 2. So that you have two values. You have x is equals to 4 or x is equals to yes or, because any of the values will satisfy the value of x equals to 0. So that minus 2 plus 2 will give us 0, plus 2 plus 2 will give us 4. So these are the two values of the x. Do you have any question? So the input is x equal to 0 or 4 when the output is minus 3. So once you have done that, you have already solved the problem. Have any question? We are still solving for the using the equation to, as our question is exploring inverses of a function. Once we are done with the exploration, we now define what the inverse is all about. So these problems we are solving will enable us to understand how to find the input when the output is given by using the given simple equation f of x equals to y. So do you need one more example? Let me do one more examples and then we proceed. Okay, the third one, the output is minus 3 as well, so you are required to find the input. The third example, f of x is equals to minus 2x over 3 plus 1. So you are required to find x, solve y equals f of s for x, then find the input, that is x, when the output is minus 3. So the first thing is to set f of x equals to y. Set f of x equals to y. So this gives us y equals to minus 2x over 3 plus 1. So once you do that, you subtract 1 from each side. Subtract 1 from each side. So this gives us y minus 1 is equals to minus 2x over 3. It's like making s the subject of the formula. So multiply each side by the inverse of this. Multiply each side by minus 3 over 2. The inverse of this to make s the subject. So this is minus 3 over 2 in bracket y minus 1. So once you multiply this will be minus 2x over 3 times minus 3 over 2, so that they can cancel out to give us what? X. I hope you are following. So from here, so this is the value of x. So we have So we have that our x is equals to minus 3 in bracket y minus 1 all over 2. So this is the value of what? X. So you were asked to do what? To evaluate, to find the input when the output is minus 3. The second question, given that y is equals to minus 3, find x. X is equals to what? So from here I have x equals to, wherever I see y, I put minus 3. Minus 3 in bracket minus 3 minus 1 over 2. So this gives me minus 3 times minus 1 minus 1. Minus 3 minus 1 will give us minus 4 over 2. So this can cancel out to give us what? Minus 2. So minus 3 times minus 2 will give us what? 6. So this is the value you are required to solve. Once you have done that, you can now state here reasons, and that is all. Have any question? So the input is 6 when the output is what? Minus 3. So the input is what? 6 when the output is what? Minus 3. Have any question? Do this. You can do this. Please try do this once and bring them to me. Do this once. First one is f of x equals to 3x plus 5. The second one is f of x is equals to 2s raised to power 4 minus 5. And the last is f of x is s minus 5 raised to power 3 minus 1. Solve is using the output of minus 3. Find the value of x, then find the input when the output is minus 3. So we can proceed. You can pause the video, copy it out so that we can proceed. Alright, we are still in the inverse of a function. So let's proceed. Since you don't have any question, inverse function of the type inverse function, let f of x equals to 3x plus 5. Solve for y equals to f of x. Solve y equals to f of x for x. We are now to define the inverse function. So from here, set exactly what we did in the past, y equals to 3s plus 5. Then subtract 5 from both sides. We have y minus 5 equals 3x. Divide both sides by 3. You have y over 3 minus 5 over 3 is equals to x. So At this point, replace y with x and s with g. Replace y with x and s with what? G of x. If you do that, then we have g of s. Replace y with g, replace y with x, s with g of x. So we have g of x equals to s over 3 minus 5 over 3. So from this point, we say that g of x is the inverse. G of x is the inverse function of what? F of x. So we say that g of x is the inverse function of x. So in this case, we can compare g of x and f of x and plot the graph. You can use the graphing calculator. So in this case, we now have f of x. We now have f of x. Let me clarify. We now have f of x to be what? 3x plus 5, and our g of x to be equals to what? S over 3 from what we got minus 5 over 3. So looking at this, g of x is the inverse of f of x. G of x is the inverse function of f of x. So if you use a graphing calculator, graph the two functions, what did you notice? Use graphing calculator. To graph the two functions. What did you notice? So if you use a graphing calculator, graph this function and graph this function. So what is your own observation? Let's draw the graph in one. If this is the graph, so we are coming to inverse function. If here is 10, here is y, and here is x. So this can be minus 10. Here is 0. Here is minus 20. We have minus 10 here. We have 10. We have 20. So from here, the first one we cut here is a straight line. The second one we cut from here. This is how it's going to go. So if you use your graphing calculator, this will be f of x, and here will be what? G of x. So the graph will look like this. You see that if we draw a horizontal line, if a horizontal line is drawn here, this horizontal line of reflection, I draw a line here to to pass, it must pass through the origin, and as if it passed through the intercept. This line y is equals to x is called the horizontal line of what? Reflection. So what am I trying to explain on these two when we use graph to graph the two function? So what am I trying to explain? I can now, let me, so we notice one thing when we graph the two function. We notice that the graph of G is a reflection. The graph of G is a reflection of the graph of the original function. The graph of G. So the graph of an inverse function the graph of an inverse function is a reflection of the original function. The line of reflection, this is the line of reflection. This dotted line is y equals to x, because when s is equals to 0, y is equals to 0. When s is equals to 0, y is equals to 0. So we put it here and use the line to draw it. You will see that at the point of intersection, the line passes through the through the intersection of the two lines. This is possible for linear equation, for linear function. If you go to nonlinear function, there is no guarantee that they are possible that the line will definitely pass through the point of intersection. So we have to put some condition when we go to linear function for such a condition to be held. For such condition to be held, possibly. So let's proceed. So I'm giving you some instances. We have done something like that, a reflection when we are treating radical and rational and polynomial functions. One is a reflection of the other in the x-axis and the other one in the y-axis. So inverse of a function is a reflection of its original function. Can we proceed? This is, you can do it. There are other ways you can find the inverse of a function, not only by graphical method. You can as well do that by algebraic method. So let's proceed to solve an inverse of a function using algebraic method, and at the same time illustrating it graphically. So if you are ready, let's proceed. To find the inverse of a function algebraically, to find the inverse of a function algebraically, switch the rows of s and y. Switch the rows of what? S and y. And then solve for y. And then solve for what? For y. If you switch the row of s and y, then solve for y. For example, example 1. So let's go for examples. The first example 1, given f of x is equals to 1/3 times x minus 2. So find the inverse of this function. Find the inverse of the functions. Find the inverse of the function. So already we have solved some problems when we are talking of input and output. So it is the same method you use, but in this case you have to switch the rows of s and the y. So let f of x equals to y. In this case we have y equals to s/3 minus 2. We are trying to find the inverse. So at this point, switch s and y. Switch s and y means change wherever you see y, you put s, wherever you see s, you put y. So from here I have x equals to y/3 minus 2. Switch s and y means wherever you see s, put y, wherever you see y, put s. This is to enable us to find the inverse of the given function f of x. So in this case we can now solve for y. Solve for what? Y. So in this case, what can we do? Add 2 to each side. Add 2 to what? Each side. We have what? S plus 2 equals to y/3 . Add 2 to each side, get y/3 minus 2 plus 2. So minus 2 plus 2 is equals to 0. So we can remove it. The next is to do what? Multiply each side by what? 3. Multiply each side by 3 to do what? To remove the 3 in the denominator of y. So this will give us 3 in bracket s plus 2. This gives us y/3 times 3. So that 3 can cancel out to give us y. So we have that y is equals to 3 in bracket s plus 2. Hope you are seeing it. We have that y is equals to 3 in bracket s plus 2. So this y we got is called the inverse of f. Therefore, the inverse of f function f is what? G of x equals to 3 in bracket s plus 2. So that is it. Once you solve for y and got the value of that y is the inverse of f, the function given. which is g of x. The inverse of f is g of x equals to 3 in bracket s plus 2. If you open bracket, the 3 will affect everything to give us 6x plus 6, to give us what? 3x plus 6. So this is the inverse of f. We have solved this before, so let me solve one more problem for clarification. You are given the second question. Find the inverse of the function. The second question, f of x equals to minus 3x. So how do you find the inverse? To first set f of x equals to y, which means y is equals to minus 3x. Once you done that, you do that, y is equals to minus 3s. Switch x and the y means change their position. This is y, it will be x, minus 3, s will be y. So once you do that, I want to make y the subject. Divide each side by what? Minus 3. So I have s over minus 3 is equals to minus 3y over what? Minus 3. So this will give me what? Minus s over 3 is equals to y. So y is equals to what? Minus s over what? 3. So this value I got is what? The inverse. Y is equals to what? Minus s over 3. Therefore the inverse of f, the inverse of x is what? Is g of x equals to minus s over 3. So this is how to find the inverse of a given function. Have any question? Let's go to inverses of nonlinear function. Can find the inverse, do this one. First one, f of x is equals to 3 in bracket minus 2x plus 1. Second one, f of x is equals to minus 1 over 7 s raised to power 3. So do these two. Find the inverse of these two functions. All we did so far is inverse of what? Linear function. Now let's find the inverses of nonlinear function. All we have been doing is what? Finding the inverse of what? Linear function. Then let's find the inverse of what? Nonlinear functions. So finding the inverses of what? Nonlinear function. Inverses of non inverses of nonlinear function So having known the inverses of linear function, let's also do nonlinear function. Previous example shown that the inverses of linear function were also function. Previous examples inverses of linear functions are also functions. Previous example. However, inverses are not always function. In reality, inverses are not always a function. So we are going for nonlinear, because the graph, if you look at the graph of f4 of x equals to s raised to power 2 and f4 of x equals to s raised to power 3. If you check the graph of these two functions, so the graph of f4 of s equals to s squared and f of s was shown are shown along with their reflections in the line y equals to x. Let me just give a graph for clarifications. This is the first graph. I'm coming to that. So the second one, this graph will look like this. So we are looking at these two graphs. There are a few things, there was something I want to explain here. We have also so this is, I have done the one of, let's this come to this one. It might not be drawn to scale, but there's something I want to explain. So for clarification, this one will come from here and there. But I hope you are seeing it. If you draw a line of, there's a line of symmetry be in this form. This is a line passing through this. And I have something like this. Alright, if this is a line, horizontal line, this line is y equals to x, here is y, here is x, so that this function f of x, this is equals to s squared, and this function here, this one is x equals to y squared. So there are a few things I want to explain to you here before we proceed. This line is equals to f of x equals to s raised to power 3. This is g of x equals to s raised to power the cube root of 3. Alright, so let's proceed. The graph of f of x and f of s raised to power 3 and f of s raised to power 3, f of s raised to power 2 and f of s equals to s raised to 3 are shown along with their reflections in the y equals to x. So if you draw a line here, this horizontal line of text, this is y equals to x. You may not see it very clear. So notice that the inverse of f of x equals to s raised to power 3 is a function. Notice this is a function because this line, as you have seen, this moves like this, and this one goes in this form. It's a function, but the inverse of f of s equals to s raised to power 2 is not a function. This is not a function. If you look at this, this has a negative. It has a negative. This is not a function. S is equals to y squared. It's not defined on x, so it's not a function. And why this one is a function? So, and for that reason, s equals to y squared is not an inverse of s squared, but cube root of x is an inverse of s raised to power 3. So one is a reflection. This is a reflection of the original or the parent's function, but this is not, as it tends to focus on the s-axis, while this one has a value along this side when s is less than 0. At this side, s is greater than 0. But we know that if you solve this further, we have that y will give us plus or minus the square root of what? X. Is it not? So when y is equals to minus the square root of x, so this is not a function, and this one, what will I say, the inverse is not a function. Why the what will I say, the original parent's function is assuming a function. So in order that this has to be a function, there must be a restriction placed. There must be a restriction in order for it to be a function. We must place a restriction to make it a function. So let's proceed. So in order to make it a function, we must also restrict f of x. When we restrict the parent's function, the original function, this becomes a function. What do I mean by restricting it? We know that f of x is equals to s squared. Placing a restriction on the domain of x will remove maybe this side, so that we have only one side, and maybe we remove this one. As we place a restriction on the parents, that restriction on the parents, on the original, will affect this. So that, let's say from here now, we say that x is defined as greater than or equal to 0. If you place a restriction on this, as s is greater than 0, this side will go. We don't need this side. in that case, whatever we got, we also the what will I say, the inverse will no longer include this side. It will not reflect. It will include only on the value as x is greater than or equal to 0. So it will go this way, while the parents will move in this side. Do you understand? In this case, if we place a line of horizontal line of that passes here, you see that the g of x is now an inverse of what? An inverse of f of x, and it's a function. So what I'm trying to explain, g of x can be an inverse of a given function, but it cannot be a function. So in order to be a function, there must be a restriction placed on f of x. This is possible only for even for this s squared, maybe s raised to power 6, maybe s raised to power 4. Place a restriction. So in this case, if we restrict maybe s less than or equal to 0, then the inverse of this will be s equals to minus the square root of 0. Do you understand it? Its inverse will be what? Negative. If x is less than or equal to 0, its inverse will be negative 0, negative the square root of x. But if its inverse is a positive, as in s greater than or equal to 0, g of x must be equal to the square root of x. In this case, it is a function, as you have seen. Do you understand? So that is it. So placing a restriction on the original function will enable the function to have the inverse of that function to have the inverse of the given function to be a function. So when you place a restriction, it will enable it to be a what? A function. So let's do some maybe let's solve some problems here for a clarification. Let me give you one more example. Nonlinear function, inverse of a nonlinear function are not always a function. Unlike linear function, the inverses are always a function, but that doesn't hold for a nonlinear. For example, look at this example. f of x equals to s raised to power 2 for s greater than or equal to 0. So restriction is placed. So let's see if you can find the inverse and then graph the inverse and the function to see how it looked like. So let's set f of x equals to y. We have y equals to, find the inverse of f and graph them. So let's set f of x equals to y. We have y equals to what? S squared. So switch s and the y. Inverse is the method we use is still the method to find the inverse. So if you switch them, you have x equals to y squared. Square root each side. I hope you are following. Square root each side. We have plus or minus the square root of x is equals to y. That is, y is equals to plus or minus the square root of x. So because we have a restriction here, restrict the domain. I hope you are seeing it. Restrict the domain. The radicand of a square root cannot be cannot be negative. Restrict the domain to s greater than or equal to 0. So if we restrict the domain to s greater than or equal to 0, as we have seen here, what is the reason? The radical of a square root must be non-negative real numbers. So once we have done that, you see that the inverse of f is g of x equals to what? The square root of x. The inverse of f will be what? G of x equals to what? Square root of x, because the restriction has made it possible. So if you use the graphing calculator, graph the two functions, you will see you have something like this. Mind you, this pass through the origin. This first, and the second will go like this. So the second will move like this. So this is how it's going to look. The SY Isaacs. So this is how it's going to look. If you draw the line of horizontal line, if you draw this reflection, this is a line of reflection, not horizontal. This is a line of reflection. So in this case, when I have y equals to x, this is the function, and this is what? The inverse. So because of the restriction we place here, our g of x will only go to this side. We have already done radical graph when we are treating rational and irrational exponent. So the graph will look like this, because we have restricted it at s greater than or equal to 0. We don't have this here, so this is limited. We remove it so that it is in this form. G of s is now a function, it's now a function of f of x, an inverse of f of x, because of the restriction we placed. So it is only at this point we can say that g of s is an inverse function of f. Do you understand? This is applicable to nonlinear, inverse of nonlinear function. Although we can easily test for inverse of a function without solving the function algebraically. We can test if a given function has an inverse function. We can test if a given function has an inverse function. This is possible by the use of what? Horizontal line text. So let's move. Do you have any question? So let's go into horizontal line test. Horizontal line test for inverse function. So horizontal line test for inverse function. What does this state? The inverse of a function f is also a function if and only if non-horizontal line intersect the graph of f more than once. the inverse of what? The inverse of a function is also a function if and only if and only if no horizontal line intersect the graph of f. The graph of f more than once. So the inverse of a function is also a function if and only if no horizontal line intersect the graph of f more than once. So in this case, we can now test for inverse of a nonlinear function to see if it is a function, because we told that a function, inverse of a function is not always a function. So by using an horizontal line test, we can be able to conclude if a given function, inverse of a given function, is also a function. So if you look at a graph of, considering these two graphs, if you consider these two graphs, this is a graph of f, another graph, this is y, this is x. So looking at these two function graph, this is a function of x, f of x, this is another f of x. So by using a horizontal line, draw a horizontal line text, draw here again. So which one is a function? Which of the two graph of function is an inverse or inverse a function? Which of the two function has an inverse function? Using a horizontal line test, the inverse of a function is also a function if and only if no horizontal line intersect the graph of f, that is its parent's graph, more than once. F of x, this is a horizontal line, it intersects the graph only once here. Therefore, this is a function. Inverse is a function. Intersect here and intersect here. This is not a function, is it not? You can now write inverse not a function. So this is what the horizontal line test states. Do you have any question before we proceed? Inverse is a function. If you find the inverse of f of s, this particular graph, this particular function, its inverse is a function. If you find the inverse of this, the inverse is not a function, as we have done in the previous examples. So can we continue? Let's solve some problems for clarification. So let's do some example. Determine whether determine whether the inverse of f is a function, then find the inverse. Determine whether the inverse inverse of f is a function and then find the inverse. So this is the question 1. f of x is equals to minus s raised to power 3 plus 3. So you have seen it. Determine whether the inverse of a f is a function and then find the inverse. Since we use horizontal line test to determine for nonlinear function, then the graph of this function will enable us know if it is its inverse is a function or not. So if we graph this function, considering the fact this is 0, by this is vertical, this is a vertical translation 3 unit, and here is negative. If it is positive, it will go like this. Is it not? It will move like this. Because it's negative, we can start from here. So looking at it, we only wanted to see the graph. So then that's here. So this is how the graphs look like. So once you have gotten the graph, draw a horizontal line, because that will enable us know if it has is intersected in more than once. Anywhere you wanted, if you do it like this, you see, mind you, here is a clear curve. So you can't think that once it cut it here, it cut another place. Just this is a sketch. So if you draw a horizontal line, even though it's here, you will see that it cut only at one point. So by the line, horizontal line test, by applying horizontal line test to the graph of f, the inverse is a function. The inverse of f, the inverse of what? The inverse of f. I hope you are following. The inverse of f is a function. By applying horizontal line test, the graph of f, applying the horizontal line to the graph of f, the inverse of f is a function. So this is what we are required to find. Determine whether the inverse of f is a function. You have already determined. So the next is to do what? To find the inverse. So f of x is equals to minus s raised to power 3 plus 3. Set y equals to f of x. So y is equals to minus s raised to power 3 plus 3. The next is to switch s and the what? Y. Hope you are following. Switch s and y. We now have s equals to minus y raised to power 3 plus 3, and then you solve for y. Solve for what? Y. So to solve for y, we'll 3 across is equal sign. We have s minus 3 is equals to minus y raised to power 3. Then you divide by what? Minus 1 to make y, the y raised to power 3, the subject. This will give us y raised to power 3 equals to minus 1, because minus 1 is like multiplying the numerator by minus 1, this is equals to x minus 3, so that when you open bracket you have minus x plus 3. The minus 1 times this will give you minus s, minus 1 times minus 3 will give us plus 3. Have any question? Sorry. So find the cube root of both sides. Find the cube root of both sides of the equation. You have y raised to power 3 times 1 over 3, because you are looking for the cube root, is equals to y equals to what? The cube root of minus 3 plus 3, minus s plus 3. Have any question? So this is what you will get. If you don't have any question, we can proceed. So from here we can now say that therefore the inverse of f is what? The inverse of f is what? Is g of x equals to the cube root of minus x plus 3. That is the inverse, and that is what? The text. The inverse is a function. So can we continue? Alright, let's do more examples for clarification. Then we proceed to more examples for clarifications. So example 2. Have any question? It's okay. Inverse, let's repeat the topic. The inverses of a function, the inverses of nonlinear function. We have done that. You are required to determine what? Determine whether the inverse of f is a function. Then graph the what? Graph the function. Alright, let's proceed. So example 2. In this case, example 2 is f of x is equals to the square root of x minus what? Minus 6. F of x equals to the square root of x minus 6. So in this case, we now proceed. How can we determine whether the inverse of f exists? To do that, we have to graph f and use horizontal line test. So let's graph it. If you are looking at this is a closed function. In this case, we are told that here horizontal translation by a unit of 6 by a factor of 6 units to the right. So it will start from here. So this is how the graph may look like. This is a graph of f of x. So the graph of f of x, by using horizontal line test, only cut at one point. So once you have done that, horizontal So no line test, I hope you are following. No line text, no line test intersect the graph. No line test intersect the graph at more than one point. Intersect the graph at more than once. So once we have done that, which means this has a function, the inverse is a function. The inverse of f is a function. The inverse of f is a function. So let's solve for the function. Set y equals to f of x. In this case, y is equals to the square root of s minus 6. Once you do that, the next is to switch s and y. Switch s and y, which means here will be x equals to the square root of y minus 6. Then find the square of both sides. Square each side of the equation. This will give us s squared equals to what? Y minus 6. So then add 6 to both sides. Add 6 to each side. So add 6 to each side. This will give me s squared plus 6 equals to y. So y is equals to s raised to the power 2 plus 6. So this is the inverse. Once you arrive at this point, you already solve it. So the inverse of f, the inverse of f is what? G of x equals to s squared plus 6. So this is the inverse. You have any question? So let's continue. I can now clean it, so we can continue. Can we continue? So let's solve example 2. Determine whether the inverse of f is a function and what? And graph, and then this is then. Look at this thing very well, and then find the inverse. So the second question is, the third question is f of x. Please, I hope you are following. Minus the cube root of 2x plus 4 divided by 3. The cube root of what? 2x plus 4 divided by 3. So to find whether the function as inverse of this function is also a function, use the graph. You have to graph the function, graph f. So when we graph f, you see it, graph f. So here be 5, here be 5, here be minus 5, here is 0, and here is minus 1. If here is y, here will be also x. So from here, you can now graph it using a graphing calculator. Make it easy. or else you have to find the zeros of the function, and then when s is equals to 0 you find the value of x, and then you have to use the zeros to plot it. Otherwise, graph it using the graphing calculator. In this case, we have, this is how it's going to look. So are you seeing it? This is how it's going to look, which means it intersect s somewhere here and intersect y at this point. Because it's a cube, this is how the graph is going to look. In this case, if you use horizontal line test at any point, you see that it only cut the graph at once, only one point. It doesn't cut it more than once. So you can now state that the horizontal line test cut the graph, cut the graph of f at only one point. So once you have stated this, you can now conclude that the inverse of f is a function. So this is what we are required to verify. So the next is to do what? To find the inverse. Find the inverse. Find the inverse. So to find the inverse, set f of x equals to y. Set f of x equals to what? Y. So to find the inverse, you have to set f of x equals to y. So this gives us y equals to minus the cube root of 2x plus 4 divided by 3. So from here you can switch x and y. Switch x. So you have to switch s and the what? Y. So this gives us x equals to minus the cube root of 2y plus 4 divided by 3. So once you have done that, you begin to make y the subject of the formula. Multiply each side by minus 1. Multiply each side by minus 1. So we are trying to make y the subject. This gives us minus x. If multiply each side by minus 1, this minus will go to give us the cube root of 2y plus 4 divided by 3. Then the next is to find the cube of both sides. Cube of both sides. Find the cube of both sides. We have minus s raised to power 3. This will give us 2y plus 4 divided by 3. I hope you are following. The next is to multiply each side by 3. We are making y the subject. Multiply each side by 3. So if you multiply each side by 3, this will give us minus 3s squared, minus 3s raised to power 3 will give us 2y plus 4. Then subtract 4 to each side. Subtract 4 because each side, this will give us minus 3s raised to power 3 minus 4. This gives us 2y. So the next is to do what? To divide each side by 2. Divide by 2. You have to divide each side by what? 2. If you divide each side by 2, we don't have enough space. This will give us y equals to minus 3s raised to power 3 divided by 2 minus 4 divided by 2 give us 2. So this is what you will have. Y is equals to minus 3s raised to power 3 divided by 2 minus 2. So g of x, once you arrive at this, you already solve it. So there is no space, so this is equal to what? G of x, which is the inverse. Do you have any question? So g of s is equals to negative 3s raised to power 3 divided by 2 minus 2. Now do this once before we proceed. Do this once. The first one is f4 of x. Determine whether its inverse is a function and then solve the function, solve the inverse. The second one is f4 of x equals to minus 3. This is 4x minus 7, 4s minus 7 divided by 3. And the last f4 of x is equals to s raised to power 4 plus 2. So do these 3 to see if you understand how to determine the inverse of a function and find the inverse. Alright, so let's proceed. It's going to be a long lesson. Do you have any questions so far? Okay, let's continue. We are still on mathematics, guided by Manzana. Sorry. So we are now verifying function. Verifying function are inverses. Verifying functions are inverses. So what does this mean? To verify if a function are inverses, that is, if a function are inverse to each other, as we have treated at the beginning, input and output, and then we did some examples. So in order to verify if functions are inverses, there are some things we have to know. Let f and g be inverse. Let them be inverse function. If let f and g be an inverse, if f of a, if we put an input of an f and it gives us result of b, then g of b, if that result, the output we put in, that is, if we put a value a as in a function f and it gave us an output b, and then we put that output in g, it gives us a, it gives us the initial input. Then in general, if this is occur, then in general, f of g of x is equals to x. This is pronounced as f of g of x. That is, we take the values of g and put it into f. If it's a function of x, if the result is equals to x, and also g of f is equals to x. If this g of s, you put it in f, it gives us x, and f of s, we put it in g, it gives us s. Then these two, then f and g are inverse functions. If these two conditions are hold, then f and g are inverses. Functions. Inverse functions. So one thing you have to know about inverse functions undo cancel each other, because when you evaluate a function with a specific input, it's a function, you evaluate with a specific input a, and then evaluate it inverse using the output. This is the inverse of f, which is g. Evaluate this inverse using the output. You obtain the original input. So when you evaluate a function with an input a, you evaluate it and the result equal to b, then evaluate the inverse of f with the output, and the result gave you original input. Then these two are inverse of each other. That is it. So in that case, if I put a function of g into f, the result give me x, and I put the function of f into g, and the result give me x, then f and g are inverse functions. So let's proceed and do some examples for you to see how this works. So the first example, determine whether the functions are inverse functions. Determine whether the functions are inverse functions. So we are required to determine whether the functions are inverse function. The first is f of x is equals to 8s raised to power 3. G of x is equals to 3 the cube root of 2x. So once you are given this, if f of f and g of x are inverse function, they have to state the condition. If f of x and g of x are inverse functions, if f of x and g of x are inverse functions, then f of g of x will be equal to what? G of f of x, that will be equal to x. This is the condition if they are inverse function. So let's test it. F of what? G of x. So in this case we put this here. This gives us 8. Wherever you see x here, we put all this value wherever you see x. So this gives us what? A cube root of 2x raised to power 3, because of 3 here. So the index of the radicand will do what? Clear the exponent of the 2x to give us what? 8 times 2x. So this will give us 16x. Is it not? If you simplify, we have been doing this often and often. So you do the other one, g of f4 of x. So this will give us what? You take the values of all these values and put it here in x. So this will give us 3, the cube root of 2, and you put everything wherever you see x, 8s raised to power 3. So this will give us what? Opening bracket, this was 16 s raised to power 3. So if you simplify this, 4 raised to power 2 is 16, 2 raised to power 4 is 16. So there is no simplification of 16 here. Only index of the s will be cancelled out of the radicand to give us x, the cube root of 16. So looking at them, they are not equal. So from here we can conclude that f of g of x is not equal to what? G of f4 of x is not equal to x. This is not equal to s. Therefore, once you came to this, therefore, this is a sign of therefore, they are not inverse function. They are not inverse function. That is, f and g are not inverse function. So since this doesn't hold, they are not inverse what? Functions. So let's do more examples for if we can get an example that will give us functions that are inverses to each other. So let's go for second example. So looking at the second example, we are given f4 of x is equals to the 50th root of s plus 9 divided by 5. Also, you are given g of x is equals to 5s raised to power 5 minus 9. So determine whether the functions are inverses. If the functions are inverses, then f of g of x will be equal to g of what? f of x, and the result will be equal to x. So this is the first thing. So let's test for this. f of g of x, take whatever that is g, put it in the s of f. So in this case we have the 50th root x here, you put 5x raised to power 5 minus 9 plus 9 divided by 5. So this is equals to the 50th root of minus 9 plus 9 is equals to what? 0. So this gives us 5s raised to power 5 divided by 5. So the 5 can cancel out. We see that there is 5 here, there is 5 here. So the index of the radicand, we clear the exponent of the what? The radicand, to give us x If you don't know how to do it, this is equals to x raised to power 5 times this. Put it in a rational form so that they cancel out to give us x. So we have x. We have gotten the first to give us x. So we do the second one. We have done this. The next is g of x, g of f of x. So write 5. Wherever you see x, put this value. So this gives us what? The 50th root of what? S plus 9 divided by 5. Remember to put this 5 exponent minus 9. So you see there is 5 here, there is 5 here. So the radical indents we clear the exponent of the radical. This is the radical, and this, all this value here has this 5 radical, a and d, the suffix. So therefore the indents of the exponent of the radical, we clear the exponent of the radical to give us what? We'll have what? 5 in bracket s plus what? 9 divided by 5 minus 9. So that is it. As this we go, we have this. So if you open bracket now, opening bracket, we have what? Multiplication will be here. Alright, let me leave it. So opening bracket, we have 5. You don't need to open bracket. From here 5 can cancel out, is it not? There is 5 in the numerator, there is 5 in the denominator, so 5 cancel out. We have what? S plus 9 minus 9. So this can cancel out to give us x. So therefore they are equal. Therefore, since f of g of x is equals to g of f of x is equals to g of f, the result is equals to x. Since we have confirmed this to be equal, we now conclude that the functions are inverse. The functions are what? Inverse 6. The functions are inverse. So this is how to verify if a given functions are inverse to each other. That is, they undo and cancel each other. So the functions are what? Inverse. Have any question? So there is no question. You can do this one. Do this one to make sure that you understand how to find the inverse of, to verify whether two given functions are inverse of each other. So let's continue. Do this. The first is f of x is equals to 7 s raised to power 3 over 2 minus 4. G of x is equals to, in bracket, s plus 4 divided by 7, 3 over 2. So the second one, I hope you are seeing it. So f of x is equals to 2x minus 9. There's a semicolon here. It's a semicolon. G of x is equals to SC over 2 plus 9. Determine whether the functions are inverse functions. So I think we have done a lot. We have also determined is there nothing we haven't done? So let's quickly do 2 examples and then so the next we'll be doing is just solve some problems we have done or supposed to be do. We have done everything just to solve few questions and then we'll call it a day. Find the inverse of the function. Find the inverse of the function, then graph the function. Graph the function and its inverse. Graph the function and its inverse. I hope you are seeing it. All right. So the first is you are given f4 of x equals to sa plus 4 to the power of 3. So to find the inverse, set this equals to y. Set f4 of x equals to y, and the switch x and the y. If you set f of s equals to y, you switch s and y. So from here we have y equals to sa plus 4 raised to power 3. So switch the inverse 6, switch s and y, we have x equals to, we have done this before just for reflection so you'll be able to solidify, have a strong knowledge of what we are doing or what we have done. So from here I won't go into steps. Just find the cube root of both sides. We have s raised to power 1 over 3 equals to y plus 4. Then subtract 4 from each side. We have x raised to power 1 over 3 minus 4 is equals to y. So therefore the inverse of what? So the inverse of f is g of x. G of x is equals to s raised to power 1 over 3 minus 4. You can leave it in the rational form. You can as well put it in the radical form. This is the radical form. So that is how it is. You draw a line here so we can plot the graph. So putting the graph here, here is y, here is x. Here is minus 10, here is 10, here is 10, here is minus 10. So once you did that, you plot the first one. See that? You do the second one. So this is how it goes. This is how the graph is going to look like. This is f of x and this is g of x, inverse of each other. If you draw a line, let's say we draw a line here, or and this line will pass through the center. This is the horizontal line. This is a reflection line of reflection where y is equals to x. So this is how it's going to look, because you are told to plot it, because graph the inverse of the function, then find the inverse of the function, then graph the function and its inverse. So this is how it's going to look. Let's proceed and do one more examples, and then maybe one more just to refresh your mind, and then call it a day. So the second example is f of x is equals to minus s raised to power 6. This has a condition as s is greater than or equal to 0. So set y equals to f of x. So this will give us y equals to minus s raised to power 6. Switch s and y, in fact switch x and y. So this will give us x equals to minus y raised to power 6. Then multiply each side by minus 1, processes we have done before. This will give us minus x equals to what? Y raised to power 6. Find the 60th root of each side. 60th root of each side. Find the 60th root of each side. Have plus or minus the 60th root of x. This will give us equals to y. So in order for the inverse of f, so looking at this now, if we can because the condition is s greater than or equal to 0. So and the radical here has made negative. So how do we solve for this? Because the radical there's a negative there. We know that the radical of a square root must be non-negative. So there is something we have to text. We know that from here minus y raised to power 6, and we come to this point, we have to this point. In order to there's few things you have to know. The radical of, we have done that, the radical of square root must be non-negative. Must be what? Non-negative. And for such reason we drop the negative sign. In this case we have y equals to plus or minus the 60th root of x. Drop the negative. That is the first thing. The radical of a square root must be non-negative. In this case s is greater than or equal to 0, already given. So the first thing is to drop the negative. In order that when we when we are to find the function, in order for the function to be, when we try to find the function from the inverse, for this to be possible, we must take the negative part of the y. So therefore y must be equal to negative the 6th root of x. That is true. Take the negative, because if you really wanted to, this is the inverse. Therefore g of x, the inverse is g of x equals to negative the 60th root of x. Yet you can, if the inverse is the negative the 60th root of x, this is possible. Mind you, because we have already tested if two functions are inverses of each other, is it not? So which means from here I can try to find f of x again, is it not? So let's try it before we proceed into looking at the graph. So if you have g of x to be equal to negative the square root of 6, is it not? So set this equal to y. Y is equals to negative the square root of what? 6. So switch each other, we have x is equals to negative the square root of what? Y. If you switch, then divide both sides by minus what? Minus 1. Or multiply each side by minus 1, we have minus x. Minus x is equals to the 60th root of y. Is it not? Then find the 60, find the 6th, multiply both sides by the exponent of 6. So this will give us negative x raised to power 6 is equals to, if we multiply this to 6, the radicand of this will create the exponent to give us y. So y is equals to minus x raised to power 6. Is it not? So because we use g, therefore the inverse is what? Inverse is f of x equals to minus s raised to power 6. You arrive at the original function. So this is correct. So from here, you have any question? The radicand of a square root must be non-negative for s is greater than or equal to 0. Y is equals to, we already dropped the negative because it must be positive. In order this to be possible, we must take the negative. So y is equals to negative the square root of 6 of the radicand x. Because this is possible because s is greater than or equal to 0. So if we plot this graph of this, it will be in this side. It will not include the negative part of the x. Have any question? So if you look at the graph, the graph will be like this. I hope you are seeing it. Let me do it where you can see it. So draw here. In this case, the next is to plot it. We have f of x. F of x is equals to minus s raised to power 6. And the g of x is equals to minus the 60th root of what? X. So if you plot this graph, if here is plus, it will be like this, because we are considering only the positive x, it will be only here. But because of the minus, it will be like this. You have your graphic calculator, you can always check it. So this is f of x. Then the next is inverse. Inverse is negative. If it is positive, it will be like this. but because it's negative, it will be like this. So this is how it's going to look like. So it will look like this once you come to this point. So this is g of x. Then the next is to draw a line of is the line. So finally you have already you have already done all you're supposed to do. Y is equals to x. So you have already find the inverse of the function. This is the inverse. Then graph the function and its inverse. This is the how it's supposed to be. Looking at it, you see that they are inverse of each other. For x greater than or equal to 0. So do this one, and finally, before we call it a day, do this one. I have only one question here. F of x equals to 9s squared, s greater than or equal to 0. So do this one. I have only one question. F of s equals to 9s squared, since we have done greater than, then try this one, less than or equal to 0. So bear in mind that in a nonlinear function, sometimes like I've told you, the inverse are not always there, and the inverse are not always a function, so you have to make it a function with this condition given. So let's finalize for today. So finally, let me test your knowledge in inverse and which function is inverse of each other. So you were asked to determine whether each pair of function f and g are inverse. Determine whether a pair of functions are inverse. Explain your reason. So if you determine whether each pair of functions f and g are inverse, then you explain your reason. So the first is you are given this. You have x minus 2, minus 1, 0, 1 and 2. So you have f4 of x. This gives us minus 2, 1, 4, 7, and 10. So you have another one. I hope you are seeing it. You have another table. You have x. You have minus 2. You have 1, 4, 7, and 10. So g of x minus 2, minus 1, 0. Have minus 2, minus 1, 4. So this is minus 1, this is minus 2. Here is supposed to be 0, and here is supposed to be 1, 2. So determine whether each pair of function f and g are inverse. Explain your reasoning. So by merely looking at it, look at the first table. Each input of x equals to each output of second table. Input equals to what? Output g of x. I hope you are seeing it. So the table suggests that every input of x equals to the output of what? Output of the second table. Look at it. Minus 1, minus 2, minus 2, minus 1, minus 1, 0, 0, 1, 1, 2, 2. And then the output of this is equal to what? The input. We have done this formula before. Look at this output of this. Minus 2, 1, 1, 4, 4, 7, 7, 10, 10. Thus f and g are inverse. This is f of s, this is f of this is f of s, this is g of x. Thus f of x, f of s and g of x are what? Inverse. Inverse functions. What does that mean? They are inverse functions. They undo each other. They do what? They undo each other. So therefore, input of this is output of this. Output of this is input of this. So therefore, they are inverse function. So what if you are given, quickly put this one and then call it a day. So what if you are given, you have 2 here, you have 8, you have 3, there's 3 here, and here is 6, you have 4, 4, 5, 2, 6, 0. I hope you are seeing it. And in this empty you have x, 2, 3, 4, 5, 6. So g of x, you have minus 8, minus 6, minus 4, minus 2, and 0. So determine whether each pair of function are what? Are inverses. Look at the input and output you fix. Input of this, output of this. Are they equal? Are the input equal? I hope you have seen it. The input and output. Minus 1. This is 2. This is minus is 3. Minus is 4. Minus 4. It doesn't go. Look at the output of the input. Output of this. Is it equal to the input of the second table? 8, 2, 6, 3, 4, 4, 2, 5. They are not equal. Therefore, f and g are not inverse function. are not inverse function. They are not inverse function. So this is where we stop today. Endeavor to do other assignments I gave you. Present them to me for marking. If you have any question, endeavor to ask me so I can clarify the earth for you, so that you'll be able to understand the concept of what we have been doing so far. See you in the next lesson. Bye for now.